This is the Prelab video for Lab 6 temperature measurement system. And the thermistor we're using in this experiment is given here in this figure. This is an NTC thermistor, meaning for temperatures higher than the room temperature, the resistance value would be reduced to less than 10 kilo ohms. So at normal room temperature, the value should be close to 10 kilo ohm. So you put this in a bridge circuit and the output would produce a voltage change, and then the instrumentation amplifier would bring this to desired levels. The bridge circuitry we will be using is simply this Wheatstone bridge circuit. So normally in this bridge, all four resistors are equal. Unfortunately, the thermistor will have something a little bit less than the 10K, most likely at room temperature. So we use a trimmer such that at room temperature we set the value of R3 same as the thermistor. So the potential VB should be equal to potential VA. So normally VA should be half of VDD, which is 2.5 volts. So by adjusting the trimmer, we make sure that we have the 2.45 volts on terminal B. So at room temperature, we want to have VAB of 0 volts. As temperature increases, the value of thermistor would become less and less, meaning the voltage on terminal B would be less according to the voltage division. So we can simply multiply 5 volts by the resistance of the thermistor and divide by the summation of R3 and the thermistor. So once you got less than VD over 2 on terminal B, then VAB becomes more and more as temperature increases. So we have a system where VAB would be a function of temperature. So you will be recording the thermistor resistance at various temperatures such as room, body temperature, ice temperatures, and 45 degrees Celsius. This is optional. And you will record the value of the thermistor resistance, and based on that, you can calculate the VAB, and based on the amount of voltage that needs to be generated, you can design the instrumentation amplifier. This is again the bridge circuitry. It's drawn a little different. So for higher temperatures than room temperature, you will get a voltage between this plus and minus terminal shown here, and you can directly apply to the inputs of the instrumentation amplifier. Note that there are 3 op-amps. The first 2 are OP27 op-amp, and the last one, since we don't have enough OP27, is gonna be OP37 op-amp. All these 3 should be powered using dual power supplies. You should review the inverting op-amp lab that posted in the experiment folder to get an idea on how to power these op-amps. OP37 should be similar. So you familiarize yourself with that lab, and then you should construct this instrumentation amplifier based on how much voltage you're generating here and how much output should be. And the specifications were given in the lab manual. You can simply set the gain by R4 over R3 ratio. And you can keep maybe R1 half of R2. R2 half of R1. So this can be 1K for R2, 2K for R1, and then you get 1. So you got 2 from this parentheses, and the rest can be adjusted by R4 over R3. ratio. So you have a lot of choices here to set the gain. And this should be an easy experiment. And if you have any issues, please let me know.